Hello Chemners, this is the practice video for the practice quiz for tomorrow's upcoming solutions quiz. And look right here, we have a new addition to our video. We have a reference table for our use, because this quiz is very dependent on the reference table. Starting with number 1, we're going to use table G. Which salt has the greatest change in solubility between 30 and 50 degrees? So I'm going to mark up the lines here. If you look at our answer choices, looking at each of these lines, KNO3 and NaNO3 have pretty much the steepest lines. So let's highlight them over here and here. I'm going to mark up where 30 and 50 degrees are. So 30 degrees is about here, and 50 degrees is here, if I'm right. Okay. So looking where KNO3 is, let's start with that one. Goes from about 48 grams all the way up to right here where it touches this other line. That's about 83 grams. And then let's look at NaNO3. It goes from about 96 grams to about 116 grams. Now looking at the difference between these, I think KNO3 has the biggest difference. If you notice, it's a lot steeper in comparison. So for number 1, let's go with KNO3. Next, number 2, the solubility of a salt in a given volume of water depends primarily on, so salt is a solid. It's a solid which is dependent just on temperature. If you imagine pouring a solid into water, it's going to immediately plop in. So the only thing you can really change is with temperature. Mostly. A and C we didn't really learn, and then pressure is another thing we learned, but that doesn't involve with solids. That's only for gases. Pressure just for gases. Because you don't really need to press a solid into the water, it's just going to plop in. Whereas gases, it's going to move around freely. You kind of need to apply pressure to make sure those gas particles mix into the water. So that's why it's that answer. Now number 3, I told you guys to skip, and we're going to go on to number 4. Carbon dioxide gas, as I was saying before with number 2, is most soluble in water under conditions of what? So carbon dioxide gas happens to be in soda. So when is soda most desirable? That's the analogy I used for you guys, and that is under high pressure and low temperature. Choice A. Low temperature, soda is really good under low temperatures and high pressure. That's why it's freshest when it's sealed inside that can. The moment you open the can, you're releasing some pressure, and that's when it starts to fizz and sort of not get as fresh. So that's why soda is our best analogy for figuring out solubility for gases. Okay, let's move on. Alright, so according to table F, which compound is soluble in water? That means we have to go through each of our choices. Barium phosphate is choice A. Let's look for phosphate. It's right here. It's insoluble, but let's look at our exceptions. Barium is not under this exception, so it is insoluble for choice A. Next, we're going to look at calcium sulfate right over here. It's soluble under the soluble table, but calcium is an exception, making it insoluble. Next, we have silver iodide. Iodide is over here because I. But silver is an exception. Ag is silver, if you didn't know that. So that's insoluble, leaving us with sodium perchlorate. That's our answer. Alright, 6 and 7 I told you guys to skip. Now number 8, in an aqueous solution of potassium chloride, the solute is just potassium chloride. That's the thing you dump into water to make it the aqueous solution of it. Alright, number 9. According to reference table G, which solution at equilibrium contains 50 grams of solute per 100 grams of H2O at 75 degrees Celsius? So that means we have to go to table G, find 75 degrees Celsius, so that's right here. Let's mark it up. So we're going to figure out which of these is at equilibrium with 50 not 50 degrees, 50 grams. So let's scroll up here. And looking at our answer choices, we're focusing on potassium chloride and potassium chlorate. So that means we're focusing on these two lines. Let's highlight. Okay. 50 grams is over here. Let me undo that. Use this one. 50 grams here. And look at our answer choices, unsaturated solution of KCl. So unsaturated meaning it's underneath the line. So 50 grams, let's use this one. 50 grams is below the KCl point, and then potassium chlorate, 50 grams is whoa. 50 grams is actually way above it. Okay, so looking at our purple line in reference to our green dots. So here, an unsaturated solution of KCl seems to fit the bill because that purple line is right below the green dot for KCl. That's where it needs to hit for saturation. Because saturation solution of KCl needs more than 50 grams. So that's not true for choice C. Let's hold choice A off for a moment because let's look at KClO3. A saturated solution of KClO3 needs just about 40 grams-ish. So anything above that makes it supersaturated. Anything below that 40-something grams makes it unsaturated, but we have 50 grams. The only thing that fits that bill is choice A then. Now let's see why. I could see this question being sort of confusing. So let's look. Unsaturated solution. Let's go over our definitions. Unsaturated meaning below the line. Here our line for KCl is over 50 grams. If you have 50, that means we're below the line. That makes it unsaturated. Saturated is oopsies. So saturated is on the line, and then super saturated is above the line. Okay. Okay, number 10. How many liters of 0.5 molar sodium hydroxide solution would contain 2 moles of solute? So we're going to take a look at our equation. Molarity equals solute moles solute over liters of solution. It's supposed to be an L, not a 2. Okay. So we have a 0.5 molar. We're looking for liters, so 2 moles on top, liters on the bottom. So the liters is equal to, we do a proportion, so cross multiply. So 2 times x, 2 divided by, 2 equals 0.5x. 2 divided by 0.5, x is equal to 4 liters. That's our answer. All right, number 11. What is the concentration of O2 in parts per million in a solution contains that much O2 dissolved in that many grams of H2O? All right, so this is another parts per million question. I told you guys not to focus too much on this, but still, good practice anyway. So we got this many grams of oxygen over, notice what I'm going to do here. because the solution contains both water and the solute. 10 to the 6 is a shortcut for a million because there's too many zeros. And you should get approximately 8 ppm, parts per million. Now let's move on to number 14 because I told you guys to skip 13. Number 14. All right, number 14 was total number of grams of NaI needed to make 1 liter of a 0.01 molar solution. So our molarity is equal to the number of moles of solute over the volume of 1 liter. So here, the number of moles equals 0.01 times 1 is 0.01, moles. But they asked us for grams. All right. So we got to figure out the formula mass, the molar mass of NaI. So we got 23 grams of Na plus 127 grams of iodine. That equates to 23 plus 127 is 150 grams of NaI. So we got that many moles. 0.01 moles equals our X, the number of mass, 150 grams, and we get 1, so it's 1.5 grams needed. C. All right, number 15, according to table F, which of these salts is least soluble in water? So we're looking for the insoluble one. So let's look at each of our choices. LiCl. Cl is a halide and doesn't follow an exception, so that is soluble. Could cross off choice 1. All right, next is choice B, rubidium chloride. Again, also still soluble. Iron chloride, also soluble. Now lead chloride. So if we look here, chloride is here soluble, but it's combined with lead Pb, so that is insoluble. All right, last one. Okay, over here, 16, the attraction between water molecules and an Na plus ion or Cl minus ion occurs because water molecules are, so water is polar. Remember that, water is polar. If you want to look at it right here, it's asymmetrical. Snap. Asymmetrical means it's polar. All right, last question, number 17. A student prepares 4 aqueous solutions, each with a different solute. The mass of each dissolved solute is shown in the table below. So if you could barely make them out, that is Ki, NaNO3, KCl, and KClO3 in that order from 1 through 4. Which solution is saturated? Oh boy, this requires us to look at table G. Let's scroll. All right, let's look at Ki first. So that is 120 grams at 20 degrees. So first let's find where 20 degrees is. Oopsies. Oops. Scroll. 20 degrees is over here. So Ki here, the point of saturation is about 145 grams. So 120 grams doesn't fit the bill, so it's not this one. NaNO3. So at 20 degrees, NaNO3 is right here. So that is about 88 grams. Well, that looks about right. But let's check the others anyway. KCl is right here. It's about 32 grams. 25 is under it, so it's not 3. And then KClO3 over here is about 8 grams over there. 5 is right under that, so it can't be choice 4 either. So it's choice 2, solution 2. There we go.